part it will be like a here. This is called DF subtract. So this part will try to prepare the dialysis solution. Okay, taking from the concentrate and water, it's trying to prepare the solution as per the patient's required. Okay, so this is called DF subtract. Then when we go next step, there will be a UF subtract, the third one. Which one?
Which the DF3?
This is for DF, that one.
This one?
Yeah.
This area?
Yeah, dialysis flow. Okay, it's called DF, is dialysis flow.
Dialysis flow.
Yeah, dialysis flow, it will prepare over there. Okay. Then next step will go to the UF
This is
subtract.
dialysis.
It's in the up. We have here called balance chamber and called air separator. Okay. These are the solenoid valves. These are the solenoid valves. So main two things are there with a balance chamber and air separator. We call air separator and we have pump. Okay. So
What means the UF?
UF is ultrafiltration.
Ultrafiltration.
Okay. So what it's trying to see is after this DF flow is prepared with the taking the concentrate. The concentrate is the patient, they are using the chemicals for dialysis. Okay, that is called concentrate. We have bicarb concentrate and acid concentrate. There are two types of concentrate. You can see the cans are here. You see the layer of the can.
This one?
Yeah, this is acid concentrate. Okay.
And
The other one is this one. Instead of the can, we are using the cartridge. Yeah, that is called bicarb.
This one
You
bicarb.
can use the can also. So already we are having a bicarb cartridge also. This cartridge. If you don't have a cartridge, you will use the can.
So this the
That is the cartridge.
cartridge, this one.
This is all, should be always sterile. We cannot just prepare and keep it like this one. It will get contaminated. So that's why in the early stage they give us the can. So we have to daily prepare the powder. We are cleaning the powder. We have to prepare in ourselves.
What's the purpose of this one?
This is a like they are removing the what do you call body fluid from the patient. Removing the body fluid, so this fluid will get balanced. They will take inside and partially they will remove, partially they will take inside. The fluid balancing. Okay. So this is how first it will prepare that solution as per their program. It will try to prepare. Once it's ready, it will send it to the dialysis site. When they start the dialysis, it is trying to balance the fluid, taking the good water and throwing the bad water to the drain and trying to pull the concentrated water. Which is already concentrated with the water, that water it will try to take there to make a balance. Okay. So that will go with the patient's dialyzer and the connected dialyzer over there. So when the dialyzer is connected, this part is the dialyzer. Okay. Now we are connecting for simulation. This one, it's not real dialyzer. This is for simulations. So during dialysis, they will use the real dialyzer like this. Okay. So this will be the dialyzer. There are blood lines connected to the over here. This is the. Okay. This is for a blood side. We call this is for blood side. Like you can see over here, this part. Okay. There are single, double needle. We call this is for blood side. Okay. These connections are the lines are connected over there. Like a two blood line set is there. They will prime that one. During priming, they will connect it over there, and there are two needles which is connected to the patients and arterial and venous we call. Okay. Arterial and venous, it will connect it to the. It will be pull the blood from the body and through the pump. It will push to the filter. Okay. Once it's go to the filter, it will try to filter through the taking the our dialysis water. This will be connected over here. So it will try to balance. It will be going through the filters and trying to balance and try to remove the extra fluid. Whatever they make a program in that one, it's trying to remove and throw the water.
This one, this possible.
This is single use. So yeah, one part will go to the dialyzer. Once filtration is done, it will try to remove like urine, whatever the extra things they have to remove from the body. It is trying to pull and send to the drain. So blood, other side, blood will go back to the patient's body, return to the patient's body. Okay. These things we will see later. What is this? What is that thing? So basic things I am trying to show you. So this is how the water enters to the patients and then go through the dialyzer. Okay. So after this part, you see the balance chamber area. So it will come out from there, and there are a pyrogen filter we call. Here we have pyrogen filter. Okay. This will try to remove if any endotoxin bacteria is there in the machine inside. It is trying to trap over there. Okay. So this is called pyrogen filter. Now we are not connected. We are doing some testing over here. Otherwise, it will be connected here. So it should pass through this one only. How it will pass through here, see, to go there, and these are the filter. It will go from here, then it will come like that. Okay. Then it will go in this way. Same. This is another part. We call disinfection module, rinsing bridge. Okay. This part, rinsing bridge. This only this part. Okay. They have a color coded actually. You can see all the things over here, like what they are trying to color code. Okay. They are trying to indicate what is this part completely. What is trying to do over this blue, and what is trying to do this light blue, and what is trying to do this purple color, pink color, sorry, orange color, green color, and all these different colors they are trying to make it over there. So to identify easily what is going on in this part and what is going on in this part, and separately they are trying to show. Okay. So this is how the flow diagram of the total machine. Water will come inlet. Okay. It will be prepared here. It will make hot. It is not needed. Then the warm water will go to the next step of the DF flow. Then if this normal, during dialysis only it will take the bicarbonate acid concentrate. Otherwise normally it will be like a rinsing mode, it will just take the water from there and machine everywhere, and it will try to throw to the drain. So it will come from here. Finally, this is going to the drain. Okay, this is the last stage. It will be end over here. Okay. Starting from here, then go everywhere, circulating and come back and throw from here. This is normal time. During the disinfection time, there are disinfectant. We are called citric here. We have in the back of the machine. This is called citric.
DF and UF
Yeah.
section.
So once during disinfection only this part will active. So it will try to pull the solution inside and through this rinse bridge. Then it will try to circulate everywhere in the machine for disinfectant. Okay, during disinfection time. So during dialysis time, it will take water from here and get ready for the fluid, and DF preparation will be here. Then after the dialysis preparation will be here. Then it will start the dialysis with the through the dialyzer, and it will do the dialysis procedures. Okay.
Sampradai, what is this DF subrack and
Yeah, this is what I told you. It is trying to prepare all the dialysis flow. This is called dialysis
this one
flow.
PB, this one?
Yeah, this is externally. There is no any link with the dialysis inside. This is external. Blood lines.
External, okay.
This is the blood lines. Okay. The blood line is connected outside of the machines. There are arterial and venous. We call A, PB, venous pressure, PA, arterial pressure. Okay. PB is some other type of pressure. PBS having online pressures. There are different stages over there.
So that one is the tubings.
Yeah, the external tubing, that one. And this is how the patients, this is the patient suppose, okay? This is the patient. So it will take the blood from here and pulling and pushing through the pump to the, again back to the patient, okay? One in, one out, okay? Between there are a pump, blood pump is there, we will show you in the machine later. Blood pumps are there, heparin pumps are there, two blood pumps are there. So if there are single needle they call, we are not using that procedures over here. The single needle purpose, they will use double pump. Double pump will use for the single needle purpose. They will connect only one needle, pulling from that one only and sending also from the same. That is called single needle. We are using here double needle procedures. Okay. So there are double needle. This is, you see, the double needle. This is for single needle and this is for double needle. Okay. For double needle, they will use only one pump and two inserting lines, arterial and venous. Okay. So this is the external part and this is the internal part. And when you go to the next electronic wiring diagram, you can see. So this is our wiring diagram. In this wiring diagram, we will start from our SMPS. This is our SMPS. Okay. These are the main power supply. To complete power will be provided through this for each and every board over there. You can see that there are many different boards over there. So you can see how it's connected. Later on you can see this flow diagram, wiring diagram. You have manuals as well. So the main power will come to the SMPS. There are two different output of this one. 12 volts, 24 and even 5 volt. Okay. Wherever that is needed, they will provide that voltage from here to the, first it will go to the main board called supervisor board. You can see that one. This is called supervisor board. Okay. So it will pass to the supervisor board. There are many controls over there. Then there are power board 1 and power board 2. So there are different pumps, valves and different modules. They are having a different input and output. So they kept for that one power board 1 different boards and for the different purpose, and power board 2 different purpose. They will take the main supply from the SMPS and try to give what the voltage is needed for the running the pumps. Okay. So there are many other things So supervisor board, controller board, I show you in the back side of the machine. These complete boards I show you. One is SMPS, one is a control board, one is a supervisor board, then power board 1, power board 2. In between there are some small boards. You can see here, temperature board, and if it is a HDF machine, there are some HDF board. The different I will show you in the machine itself later. Okay. And when we go next, there are other boards like a SAD air detector we call. SID boards are there, heparin pump boards are there, and single needle pump boards are there, and BP module boards are there. Okay, there are many boards are there, bicarb boards are there. So these are all are boards only. Everywhere you can see they are trying to give this one and display. Finally, you come to the display. There are display inside also. There are boards in that one. And this is ABPM module. So the BP module is there. For internet cable, DCI, and some other this one supports are there. Okay, so this is the our wiring diagrams, and batteries also there. Of course, there is a backup battery in the machines. So the battery is also there, placed in the machine. Here back side, okay, SMPS switch mode power supply. Then there are one board here, control board completely. And there are supervisor board. Then power board 1, power board 2, okay, and this is a cooling fan, and there are small board placed. This is also one separate board, equal bicarb boards, and also small boards are there for the temperature, and others are like cables and everything is there. So to take the main power from the SMPS, we are trying to deliver the main.
Samparbai, can you explain once again?
Outlet for that one. This is special outlet. So
Samparbai,
yeah,
one by one. This.
So okay, this is a top level we call. Top level is having a motherboards. There are motherboards, and so you can see this is motherboard, okay, and from that one there is LVDS adapter we call, which is giving the power to the LCD display. And before we used to have a hard disk over there, okay, some machines still we can see that one. There is a hard disk, but right now we are not using hard disk. We are upgraded to the flash card, okay. This not needed a very big capacity. It's maximum we need like a minimum maximum 5 GB is enough. Okay, maximum 5 GB is enough. In the past we used to have like a 60, 70 GB the hard disk.
Okay.
But nowadays we are not going to get that type of hard disk and cables. So so the manufacturer itself, they have a the new machine, they integrated the flash card in the motherboard itself. So no need any this part. Only motherboard and integrated flash card will be there. So here now what we have, we buy the adapter separately and we try to assemble that one as per that this one. Okay, so this is our card holder, and this is the flash card. So all the program what we are installing, it will be saved over there in this card. Okay, if it is a hard disk, means in the hard disk. If not, this card, hard drive we don't have in this one. So motherboard will also keep the our program. And between there is a communication, so they are trying to communicate each other. So all the data are saved, and the CMOS battery is there, so it will be keeping your data saved. Okay, so yeah, this is RAM, and no additional things. The cooling is there, cooling fan. In the some old one we have a cooling fan, so there is no cooling fan over there. They put this one.
So it's like computer.
Yeah, it's like a computer. Mini like it's a mini
It's a
computer,
motherboard,
like small only motherboard, but not same type of computer motherboard. This is Linux program system. Okay. Yeah, Linux program system, not for the like OS system in the
Command
machine,
prompt.
Okay.
It will be blown.
Linux program system. In the past we used to have a floppy drive. We are installing with the software also floppy. With a floppy only, through floppy only.
So what is the software like OS? Linux.
Linux, yeah, Linux is our system. We will show you later the system inside. So this is the function over here, taking the software from your external and try to install in this motherboard as well as in the hard disk for flash memory. Okay. So if any software problem, anything, we have to reinstall. We have in the old mesh. This is like an old motherboard. We have here. You see that. Connections are there. These connections we will having a USB. We will connect it over there, and we have a USB stick for with the software.
So we have a backup always, backup system, like application.
We are having a software with us, original software with us, and whenever any problems come in the machine, we have to identify the problems, and we are trying to install with the software. Okay. as I told you already, again one second I will tell you this one. Whenever you are taking the things out, you have to be careful, so not to get any problem in the machine itself. So when the water is DF flow, I mean dialysate flow is prepared from the lower part. So after that stage, it will send the water to this stage. There are inlet valves, outlet valves. Okay, there are so many solenoid valves here. These all solenoid valves. Okay, there are different places they having. So they having different functions. One is opening from the inlet water, which is going inside the balance chamber. There are two parts inside the balance chamber. Okay, one side it will push it, and one side it will throw it. The other side it will push it, other side it will throw it. Like that, its function is going on like that, going up, down, okay.
So that's the throw is dirty.
Dirty water.
It's like
a
membrane.
Fresh water, yeah.
It's called
that
membrane.
is called membranes. Okay, that is called membrane. This is called balance chamber. Okay,
Balance chamber.
inside the balance chamber there are two membranes. I will show you how that membranes looks like. We have membrane outside. I will show you. Okay, so there are valves name and all. It's mentioned over there. You can see that one, like a VDABK1. VABK1. So in that also you can identify that what is that valve, where is that place. So everywhere, yeah, the valve names are there. Everywhere, everything is tagged over there.
It's
Which,
tagging over
yeah,
there.
it's a valve. What is the valve that function? Later we will see. So basically, what it's trying to do is taking the fluid and send to the balance chamber through the membrane. It's trying to balance the fluid, taking from the patient side, and good water it is trying to balance and throw the partially to the drain. Remaining it is contact with the blood. Okay. So that which concentration is prepared, it will be contact with the blood. Okay. So this is air separator. The function of this one is trying, whenever the machine is having some problem like air, it can be generate air anytime due to some valve issues or water inlet problems or anything in between broken. So there will be air actually. But what it is trying to do is, it is trying to pull the air from here and it is trying to send to the degassing. This is called degassing part, chamber. It is trying to suck the air and try to clear the good water. It's trying to give the good water without air inside the machine. So if the air is coming inside the loop while running, there will be a disturb will be there. Suppose machine is running in the dialysis, the flow disturbance will come, dialysis disturbance will come. There are many other problems can create. So what it's trying to do is, it's trying to suck the air through some part and it will take over there. There will be some water. Then the air will be go down and it's trying to prepare and send the good water to over there. Okay. So wherever air try to build up, it's trying to take.
So what is the meaning of this?
Air separator.
Air separator.
Yeah. It's called air separator. Okay.
Once the air was separated,
Yeah.
it will
Go to the degassing. Yeah.
Degassing.
Yeah.
And then
Degassing will through that one and through other side it will try to give the good water without air. It's trying to prepare the water without air and try to push inside the machine wherever it's needed. Okay. So this is called fluid what do you call DF preparation. Okay. Sorry, UF preparation. UF, yeah, ultrafiltration time. It is trying to take the water from the prepared concentration and as per the patients, like they will program in the machine. They will program in the machine like ultrafiltration 2000 liter per hour. Okay, or 2000 liter 4 hours. Now it's a 4 hours. Normally the program is 4 hours. So they will feed like a 2000 liter. They have to remove within 4 hours from the patient body. Okay. So whatever they drink, eat, like a urine. Normally the urine we are the patients are having a good health. Kidney is good. Urine itself, it's a ultrafiltration. Okay, your kidney will do the function normally.
But if the kidney is damaged,
Yeah, that's why they are trying to do dialysis over here, because the kidney can't remove the excess fluid in your body. Okay, for that case they will make ultrafiltration how much ml they have to remove from the body. Okay, so that they will as per the doctor's order they will feed it over here. It's not our part, it is for clinical stuff. So they will feed it over there. What is the amount they have to remove for per station? Okay, per station. So they will depend on the patient weight, that they will calculate, depend on the patient weight and all these things. As per the doctor's order, they will feed it here, how much they want to remove, how many hours it will be done. Normal dialysis hours will be 4 hours, every patient. One patient has to be dialysed 4 hours. Okay, so within that 4 hours, if the 2000 they put me, 500 ml per hour it will remove. from the body, 500 ml per hour. Okay, within the 4 hours it will be completed. 2000 liter will be removed. Okay, so this is how that once they program over there. So this fluid plus what patient removing fluid, it is trying to balance. Like suppose if you remove 2000 liter from the body and you send him home, he will be get sick. He will die. You remove completely 2000 liter from the body and you didn't balance the fluid in the body. Okay, so he will get some sick or maybe he will go coma, or we don't know that. Clinically he will be affected. So that's why it's trying to give some balance. Whatever that they are removing from the body,
That's the one.
that is a concentration we are trying to return, not fully, partially. Okay, 2000 they remove, the maybe 1000 liter while going, he will be balanced. Okay,
So
because
where it will go this 2000 liter?
sorry,
Where it will go? From the body you are removing the...
from the
2000.
body, from
It will
the
be returned
blood,
back.
it's like a excess fluid, like you are drinking water. So if you are not pass the urine, what will happen? It has to go to the drain, right?
Yeah.
So this is how it's trying to do here also. The excess things it is trying to remove. Then again you want to drink for you're hungry, you need food, your energy. For that you have to give the back to your body fluid. So that is how they are trying to do with that one. They are trying to prepare this concentration, bicarb and acid concentrate. That is what we are trying to remove you from your body, extra acid. There are many acid in your body, extra things. So okay, that is how they are trying to remove from your body and try to balance with this fluid. Okay, so that is called fluid balance. Your preparation, that is what is trying to do here, and it is trying sent to the dialyzer through the dialyzer, and it will go to the patient's body. Okay, it will connect with the blood actually. With the blood, it will go to the patients. Okay, so this one.
Third stage. This third stage, no?
This is a DF tract, I told you. DF flow, dialysate flow we call. Dialysate flow like a water. Which water is coming over there, and concentrate which is coming from the concentration. Okay, citric bicarbonate acid concentration. The amount of that they needed, like they are programming. They will program here. I need a conductivity of 14.3 microsiemens per minute. Okay, this is as per the doctor's orders. Okay, they know that one. This patient, the doctors having all the history of the patients. Okay, they will write the orders to the staff. Okay, you have to remove from the patients this much conductivity. The patient's having a high concentration in his body. They will do the lab testing. In that lab test, tell them what is their blood concentration. So according to that, they will program here bicarb how much, conductivity how much has to connect with their bodies. Okay, so what they are trying to program is here. Normally they will keep always 14.3. We can give up to 16. Even we can increase in our system configuration, but normally they will not go more than 15. Okay.
So this one from the blood of the patient.
Yeah, this will not blood of the patient. This is our concentration. Okay, like a sodium, bicarbonate, calcium, magnesium, potassium. These things are contained in that one.
So it will add it.
Yeah, it will add it to the, because you are removing the these things from the blood. Okay, when filtration is going on, these particles are removed from the filter. Okay, this will be removed. So that is how the dialysis is going on. Blood and water, it is trying to remove the excess from the blood. Okay, excess fluid and dirty things from the blood. So that dirty things will be contained like a magnesium, calcium, potassium. All these things are there in that one. So these things they are trying to remove and try to balance that one. So as per that doctor's order, they will put the program over there. How much has to be removed, how much dialysate flow, how much temperature need for the dialysate time. All this program they will do, even ultrafiltration as I showed you before. So how much to be removed. Okay. So and this fluid will be prepared over there and check. After preparation, it will check. Okay, your this is conductivity sensor. There are conductivity sensor, bicarb sensor. There are temperature sensors over there. So this is be checked over there. Okay, as per your program, everything is okay. Your concentration is okay. Suppose you give the wrong concentration, it will give the alarm. Your concentration is not okay. Okay, as per that one, it's trying to prepare and send to the this track where the patient fluid prepare. Okay, the patient fluid treatment. Okay, so this is called. We are having a pump. 3 pumps are there in the machine. One is inlet pump. This is the inlet pump. We call EP. Okay, we call FPE, FPE. Okay,
FPE.
yeah, flow pump inlet. This is a water pump inlet. Okay, or degassing pump inlet we can say. This is called flow pump inlet. And one more pump is there backside of this one. Same pump backside of this one. This is called FPA. Okay, flow FPA. F
Air. Flow air.
no sorry FEE. This is FPE. That is FPA. Flow pump out. This is in. This is out. Okay, this is pushing to the patients. Yeah, in water inlet pump. Flow pump inlet, flow pump outlet. Okay. So this is how in the back side of this one you can see this is called the chamber also, whole kind of chamber. It will prepare the fluid, and this is called conductivity sensor. This is called bicarb sensor. There are temperature sensor over there. Okay, small sensors are there. You see, this is temperature sensor. Okay, there are some different sensors. So you will see front side now. Same thing you see there. This track, ultrafiltration track, balance chamber. The connections are there. Solenoid valves are there. This is the pump. FPA. Okay, pump outlet. Okay, and in the rinse bridge we call this part. I show you in the from back side. Rinse bridge is the function of this one is only taking the during the disinfection it is trying to take the solution, citric acid we call citric acid, or disinfect the machine, that one. Okay, so it will pull the solution from there, and it's trying to, it will pull from the one of this pump. I will show you which pump we will pull. Now it's like we are preparing in dialysis. Okay, so once it's full, it will send to the whole area machine and circulating for the as per the program. It will circulate with the temperature, with the high temperature. Okay, it will circulate with high temperature everywhere, and it will try to rinse out completely. So there will be any bacteria, any growth inside the machine, it will be clean. Okay. So this is called, we call piston pump. We call this, they are piston pump. They have different functions. This pump will suck the solution of bicarb. Either you connect the can here or connect the bicarb cartridge. This is for bicarb cartridge. If you are not using the can, if you are not using the cartridge, we will have one more can over here. This is called bicarb. The blue color will indicate for bicarb. Okay. And this is for concentrate. This whole concentrate. The red color will indicate you concentrate. Okay. And this pump, what it will do is, it will try to suck from whether you connect the can or bicarb. So it will try to take the solution from the bicarb. Okay. As per their pump rotation program. How much needed, how many ml needed. As per that, it will be increase, decrease the pump, and be increase and decrease. Okay. This is called UF pump, UF removal. During the UF removal, when they program like they want to remove 1 hour for 500 ml liter. So this is will try to take that one.
What do you mean the F remover?
Ultrafiltration.
Ultrafiltration.
Yeah, ultrafiltration. Okay. So it will try to remove from this pump. Okay. As per that, it will try to balance, and excess fluid it trying to remove from this one. This pump is for concentrate. For this pump, whenever you are preparing concentrate now, it is taking the water from here through this pump, and it is sent to this DF flow chamber inside. It's trying to balance, it's trying to generate the things over there, what is needed for the dialysis. Okay, it's trying to concentrate inside. It's trying to concentrate and send to the next part. Okay, this is called suction rod. Okay, both are called suction rod. This is a suction rod holder. Okay. And this is a citric valve, motor valve is this motor valve, small valve, citric motor valve. So this is circuit for that one. That circuit will be programmed over there for opening, closing, all these things will be there. Okay.
This pump, there is a calibration, how many
Yeah, this pump, if it go wrong anything, the machine will give some problem. It is during dialysis. If they complain like your thermal is too low or too high, so this pump will be responsible for that one. Then we have to calibrate this pump. If during dialysis we are getting bicarb problem, so this pump is responsible for that one. Whether it's not getting proper concentration, the conductivity test will not pass, or any other problem, pump is not working, or pump rotation is not okay, the sensor is not okay. There are sensors of every pump, behind there are sensors. So the sensors are not okay. So that it will not able to detect the rotations. So
Ah.
everything will be there. So
It will give you an alarm.
yeah, it will give you alarm.
It's the sensor.
That is a sensor. Every pump having sensor. So they will tell that what is the problem. We have to identify them. What is the problem? We have to identify. There are many more things on inside the machine. So small things. You can later see that diagram as well. And you can identify what is the sensor, what is the throttles are there, and pressure reducers are there, pressure manometers are there. Okay. And here if you see the blood side, this is called complete blood side. We call the blood side. This is for fluid side. We see now. This is the blood side. Blood side you see this is pump, blood pump, and this is called SID, safety air detector. There are blood pass through that one. In case of any air pass, it will immediately alarm and stop that one because the patient should not go air inside their body. Okay. If you go that like that, patient will die also. And this is a tubing clamp. We call it tubing clamp. Okay. And there are pressure sensors over here. Manometer pressure sensor. Patient blood side pressure sensors. Okay. Patient's blood side pressure sensors. And this is heparin pump. Okay. This is the inside of the things. If you see outside over here, you come here. So this is the venous pressure port. Manometer connection. Pressure sensor is inside. This is arterial pressure. Patient in and out pressure. Okay. Patient blood in, blood out.
In, out.
Yeah,
The
in
red.
and out. Yeah. It will take from the patient and through the pump. It will push to the patient. This is a PBEV called pressure membrane. Dialyzer pressure. It will detect the dialyzer with the what is the pressure is going on with the blood. Okay. PBE. These three pressure sensors are there for the normal machine. Some machines you will see 4 sensors. During HDF they are using the other sensors. Other pressure reduce, pressure manometer. Okay. And this is of course the blood pump. Blood pump inside you see the rollers are there. This is called blood pump roller. Okay. You can pull out this one, and we can during dialysis they sometimes need that will stuck. Stuck means they have to press this one and just pull out. Press this one and pull out. Okay.
You can remove
Yeah, otherwise normally you cannot remove. Normally it will not come out. If you press this, then only it will come out. Okay. So for safety side, we have to just press and take that one out. Okay. Like this.
So we need to clean this one.
Yeah, we have to be in between. Yeah, during maintenance or in between routine checkup, we used to check routine. We just clean like this everywhere. And it should not rotate opposite direction. It has to rotate in one direction only. Okay. It should not go back. If this go back, it will be a problem. The pressure instead of the return to the blood, it will try to suck again.
Reinfuse.
Yeah. Okay. So it should be like this.
So why it's stuck? Here it's running. It's automatic will start.
There's sensor. When you open the door, it will be giving machine will give alarm for you.
Blood pumps.
It will indicate.
Cover.
When you close, that will disappear.
Okay.
Okay, there are indications for everything here because the sensors.
So, Sampath, one more question. Last. What is SD? What is the difference between SD and SDF machine?
HD is a hemodialysis. HDF hemodiafiltration. Hemodialysis just only removing the fluid. Diafiltration is something extra things they are trying to remove from that one.
SDF.
HDF. Okay. Not extra things. It's like they are trying to more accurately they are trying to filtrate. Okay, more accuracy will be there in that filtration.
But the treatment will be the same. But
not same. It will be not same.
if suppose the one
it's like
doctor is prescribed the SD dialysis,
Yeah.
and the same patient can go to the SDF or no?
It's not necessary as per the doctor's orders. They have to do because the HTF is needed. That some patients they want to more clearance in their removal. More clearance they needed. For that reason, they will recommend to do HTF, hemodiafiltrations.
But all patient no need to
All patient
go
no
for
need.
the
No, no,
SDF.
no.
By
Only
default,
Mm.
it will start.
But the SDF machines having option for the SD
So acknowledge.
Yeah.
hemodialysis.
No, that will go away. That message, when you remove that message will go away. How to disinfect the machine? Okay. So now this machine is in the preparation. I don't want to disturb. We'll come back to here. So normally any machines and water connection should be there. Okay.
So training is finished. So we are
Water
going for the
coming from
disinfection of
this
the
one. Okay. This is machine in there. So this is called SSP connector. Instant SSP connector. So just push it and then make sure the water connection.